So this is not, and this is and, etc. So you see what Russell did was built a language, symbolic language, and not only showed that this will work for all true and false type statements. So notice, by the way, that doesn't mean that you could say this magic marker is good because the ink is still nice and heavy. That is neither true nor false when you say this is a good magic marker. Because that's, you might think, no, it's not a good one, I don't like it, for I don't know what reason, right? But I couldn't prove to you, if you didn't like it, I couldn't prove to you Taylor Swift's music is good. Or any evaluative thing of that sort, right? Couldn't demonstrate that to you, right? It's an opinion, right? And so Russell's language has nothing to do about opinions, only facts. Only facts, right? And notice, as a result, when you get to the actual beginning of the Tractatus, the part that, so this is still part of Russell's, get to the very first statement here, okay. There's his preface. Okay. So notice statement number 1. The world is everything that is the case. What does he mean by that? 1.1 explains statement 1, and that means the world is the totality of facts, not of things. In other words, the world he's talking about is what we know. Remember how we've worked our way towards that? We get to a point where we're not sure how to describe this is real and this is just mental, because we get to the David Hume and we end up, well, wait a minute, everything we perceive is what we're perceiving. This is phenomena. How do we know that this phenomena is real and this phenomena is not? Oh, we get into trouble with that. But so in any case, what we mean by the world, says Wittgenstein, is the totality of facts. The totality of facts. And so it's true or false statements. You might think, well, wait a minute, it's just all the true statements. But actually, it includes the false statements too, because I know that these are false, and that's part of the world of facts, right? Okay. Now, once you're in this language, there were issues that they had not figured out, obviously. We still haven't figured out all the issues. This is an ongoing project still. Oh, and I should mention that, no, it's not that. The statement number 1 is the world is all that is the case. There's actually only 7 statements in the entire thing. I'll show you why. Statement number 2. Where is it? There it is. Statement number 2, what is the case, the fact, is the existence of atomic facts. So a fact might be a statement, but atomic facts are the simple statements that might be combined in the more compound statements. So how do you figure that out? Let's move to statement number 3. Notice all the other statements are explaining statement 1 and 2 so far, or explaining statements explaining 1 and 2. That's what all these other are. So if I look at 2.031, that's explaining 2.03. And 2.03 is explaining 2. You see how that works? Basically. Okay, so let me get to number 3. The logical picture of the facts is the thought. So if you have a logical picture of all the facts, that's the thought. That's what he's calling it. So an atomic fact is thinkable, means we can imagine it. The totality of true thoughts is a picture of the world. Okay. See why people might think this is genius, because if you don't understand what the hell he's talking about, you might explain it by saying, "Oh, he's got to be a genius and I don't get it." On the other hand, if you do get it and you think, "Wow, that's simple, it's genius," to be able to say it that bluntly, essentially. And being a genius, I still think is you're all on your way to become. Is it geniuses or genii? I don't know. Depends, I guess, on whether it's Latin or Greek. Okay. So the thought, number 4, is the significant proposition. That doesn't seem like much of a leap. We've gone through a whole series of explanations, and we've just gone a little bit further. The totality of propositions is the language. Notice, this is totally leaving out all of your values and all your opinions. This is bare bones. This is what a computer can talk about. True or false, true or false, true or false. Computers can't do value. We can say, okay, this is value, and the computer can say, okay, that's a fact. But actually, we've lied to the computer if it interprets it that way, because we might have multiple people having different values. But so this clearly shows that there's a limitation on computer thinking. So if we get into the issue of whether or not a computer could replace us, well, one of the things that's different is that we have values. Computers, so far, if they're going to speak a computer language, can only talk about true or false, true or false, true or false, true or false. They can't say, wow, that's, some people like that. It's not in their ballpark, right? They don't know how to do that. We haven't programmed to do that. It's kind of one of the interesting things about large language models is that we say, okay, if you have these words, then this word should be the next one. Should is a value. Wow. So we've given computers directions to actually have a value in that sense, to pick by majority. This is the next word that should follow in that sentence, right? So the thought is the significant proposition. And now we're getting close to where he dovetails into the language itself. It's really in 5 where he gets into that. Let me get... Notice not P there. So one could then, for example, say that P signifies in the true way that not P signifies in the false way. So he's picking up into the language here. And notice a double negation, not P equals P. So at least in English. Now if you're in French, je ne sais quoi, je ne sais pas. There's a double negation there, but it just means one negation. In English, if you say, I don't know nothing, literally that means I know stuff, right? Unless you're, you could get into a vernacular where you can end up using a double negation to just imply a strong negation in English. So here's an illustration to explain the concept of truth. A black spot on white paper, the form of the spot can be described by saying of each point of the plane, whether it is white or black, etc. Notice he's using truth value in Frege's terminology. So he's involved in the whole mix here. The object of philosophy is the logical clarification of thoughts. Philosophy is not a theory, but an activity. A philosophical work consists essentially of elucidations. The result of philosophy is not a number of philosophical propositions, but to make propositions clear. Okay. Keep in mind that at this time, clearly that's what he thought philosophy was. Obviously, philosophy is way more than that. I mean, we know that. He did not, by the way, he didn't really have that much study in philosophy. His focus was on engineering till he made the switch to be interested in the business that Russell was involved with, was clarifying language. God bless you. Psychology is no nearer related to philosophy than is any other natural science. This is all interesting stuff, but we'll see that even he thinks he's wrong about all of this later. Okay, so here he's talking about a series. Notice he's involved in there exists an X, and in this particular case, he's saying A is related to X, or X is related to B. So he's using a slightly different type of language in his use there. Might call that a relational predicate. Now, notice I've used only X here as my variable for my variable, but you can use Y, you could use Z. All the different letters basically in this language have a particular use. So capital letters versus small, etc. And by the way, one of the points of the Principia was to demonstrate that all of mathematics is based on logic. And if you remember logic, there's only three basic rules: the law of identity, the law of the excluded middle, and the law of non-contradiction. So there's only three basic laws. Built on that, you can end up building the entire edifice of logic. And then what Russell does is go on and show that 1 + 1 = 2 is explainable using logic. Takes 3 pages to do in the Principia, which is actually hilarious if you're into that kind of humor. Because 1 + 1 = 2. 3 pages to prove it in logic. That's hilarious. That's hilarious if you're there. By the way, what's the funny math joke between the year 1729? Okay. Just save it for later, look it up later. There might be multiple jokes there. I just learned it this morning. So, but that's because I don't have a life, I suppose. Okay. So fx, let's go on. I want to get to 5. This is, when he gets to this is what? Is this calculus? K to the n equals, now is that zeta? Or is that chi? I don't know. My Greek is not rusty, it's just confused. Okay, so here's our first example of a truth table. And this is what a computer is actually doing. Computers aren't reading their code as I understand them. And I'm not really understanding computers, I'm understanding what computer type folks are saying about computers. That actually what they do is they run through a table-like database described by the code, which tells them P. P means a statement of any sort that's A, E, I, or O, right? Or a compound of A, E, I, O, right? You could actually have compounds of those, right? But in any case, P is either true or false, because it's a true or false statement. And remember, you know, either P is true or P is false, but you can't have both P and true, P and